This is the review for the second part of our final exam review for Algebra 1. And I think it's number 13 that we are on. Determine if a list is an arithmetic sequence. So an arithmetic sequence is one where we are adding something each time to the list. And so this first example, we start at -6, we add 7, we get to 1. We add 7, we get to 8, and so forth. And then what we'll learn next semester are geometric sequences, and that's when you're multiplying or dividing by something. An arithmetic sequence can either be adding or subtracting, because subtracting is really just adding a negative. All right, so that's an arithmetic sequence. On to number 14. Solve a system of equations using elimination. So I've given you two examples. Solve the system of equations using elimination. So a system here is two different equations, and we are looking for an additive inverse, so something we can cancel. And they've canceled right here, the -3y, the +3y, giving us 6x equals 24, so x equals 4. Then they plug in that 4 to the first equation, right? So this very first equation that we had up here, they plug the 4 into x, and then they just solve for y. So 2 times 4 is 8. We're just simplifying that. Subtracting 8 from both sides, you get 0. So -3y equals 0, and y equals 0. So the solution is, remember I kept asking when we were learning this, is that the final answer? And we'd say no. You have to write it as a coordinate pair. So that is more of the simpler of the eliminations when we have an additive inverse. On this next equation, system of equations, we do not have an additive inverse. And so you can see they are multiplying the first equation by -2. And the second equation they're multiplying by 3, which came from the other equation, which gives us this -6 and +6, which cancel. When we add the equations together, we get -22y equals 0, y equals 0. So you plug this y equals 0 into the first equation for y, and when you solve that, you get 3x equals 9, so x equals 3. And then this is your solution. X is 3 and y is 0. So that's solving systems of equations using elimination. If you need more practice, just Google this phrase, and you can look up videos to help you with this. Determine how many solutions a system has. All right. Well, when we have a system of equations and they cross, so they have different slopes, there is one solution. When they do not cross, because they are parallel, which means they have the same slope, then there is no solution. And when they are the same exact line, so if I were to solve both of these equations into y equals mx plus b form, they would end up being the same equation, and so there's an infinite number of solutions. I'm sorry, this was number 15. Okay, and then that makes this 16. Write the equation of a trend line from a scatter plot. So what we're looking for is if you have a bunch of little dots and they have a correlation, the first thing you want to check is the line of correlation positive or negative, or the slope of that line. So the slope of that line is negative. The line is going downhill. And the y-intercept, we can see it's 9. And as we go down, like if I'm going down and over 1, I can see how that's actually going down 0.75 and over 1. And so our rise would be negative 0.75 and our run would be 1. So the main thing about this is, can you draw a line that kind of goes through some of the points, like it would fit that trend line, and could you come up with an equation? And your equation may be different from others, as long as you're showing a slope that is kind of near the data and a y-intercept that makes sense. Okay, on to number 17. Correlation of scatter plots. So all you need for this is to recognize when a scatter plot has a positive correlation, when it has a negative correlation, and when it's all over the place. There's no correlation. Number 18. Write an inequality from a graph. So some of the information on this slide is kind of erroneous. We don't really need it. So I'm just going to cross that out so you can ignore it. And you would be given a graph on your final exam. And from that graph, I want you to be able to know the y-intercept and the slope. And you can see, I draw little stair steps, that we are going down 3 over 1. And so the slope is negative 3, down 3 over 1. If I were to write that as a fraction, it would be this. Okay, and then the y-intercept is b. So are you able to put that into an equation in y equals mx plus b form? But because it's an inequality, we then have to decide, is it a solid or dotted? So it's a solid line, and we're deciding if it's shaded above or below, and it's shaded above. So we are going to fill in right here this symbol, greater than or equal to. And that is how you write an inequality for a graph. Number 20. Write the system of inequalities from a graph. And they've already done this for you, but I want you to think about how they got it. So here we have a y-intercept of 5, and we have a slope that is going down 3 over 1. And then we have the other inequality, but first let's think about the blue line. The blue line is being shaded above and it's dashed. So we're not going to have the or equal to, we just have the greater than symbol. Okay, so greater than, I'll just make a note of that over here. Greater than is dashed, shaded above. All right, and on our other graph that we have here, we have a y-intercept of negative 2, and it looks like we're going up 1 over 1. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So our slope is 1, but we don't really see it. And our y-intercept is negative 2. And why did we choose this symbol of less than or equal to? So less than or equal to and it's because it was solid and it was shaded below. This is number 21, absolute value functions, and it's not exactly like what's going to be on the final, but if you look at this graph and you look at the table, there are some relationships here, and what I want you to be able to see is that this side of the absolute value equation has a slope of -3 over 1. So it goes down 3 over 1. But then if you look at the other graph, the red line, you're going up 3 over 1. And so the slope of the blue and the red line are opposite. And that's one thing I want you to realize, what the slope is. And could you figure out the slope from looking at this table? Or if I gave you 2 points, we have a rise and a run. So our y is going down 3 and then down 3, and then it's going up 3, which is not a constant rate of change, but over a certain interval, like if you were to cut this absolute value in half and you just looked at the blue line, it would have a constant rate of change of -3. And then the red line, or the pink line, has a rate of change of 3. So this one is going up by 1, up by 1, up by 1. So it's constantly going up 1, but it starts to change on the y's. So the y is what changes the slope. So if you know absolute value, you should be fine. This is a step function, and one thing I noticed on the quiz was that people were not sure how to read this. So when we look at the miles, this interval from 0 to 1, that has a step function that is equal to 4, right? So from 0 to 1, not including 0, we get a function that equals 4, and you can see that in the function rule right here. And then for this one, okay, so we have 4, that's this step. For the next step, from 1 to 2, it's going to equal 5. So can you read a step function? And step functions do not really involve, like, none of the costs are decimals. It's a flat rate of $4, $5, $6, $7, $8. It's not like $7.01, right? There aren't decimals in this step function. So that's one thing to keep in mind, is that step functions eliminate need for decimals. So eliminate decimals. We don't have any decimals in our cost. This is number, I lost track. That was 21. This is 22 step functions. And this is 23 compare step functions. So can you read this and do you know what it means? So for cost 1, from 0 to 10, it's $6. From 10 to 40, it's $12. On our other function, or step function, from 0 to 25 is $5. So the cost for 2 is better all the way up to 25. And then from 25 to 75 is $10. So cost 2 is still better, because if I'm looking at all the way up to 40, it's $12, and we're still in the $10 range for 75. So cost 2 looks like a better deal. Yeah. So number 24 is for a piecewise function. And this is, we have one more after this. Almost done. So we have as many review questions as we have questions on the final. Can you write a piecewise function for a given graph? And on the final, it's more about, well, actually it is. Can you understand like the equation that goes to this? And looking at the first one, this blue line that I'm coloring over in red, it looks like it's just equal to -5. So f of x equals -5 if x is less than or equal to -4. So it's going from -4 all the way to -infinity. So if it's less than or equal to -4, then the function is -5. If we are greater than -4, so up here, greater than, not including 4, right? Because if we include 4, our function's -5. But anything greater than -4, our function is equal to 7, because it's going through 7. Let's look at this other piecewise function. I'm going to color it again. If x is less than 0, so here's 0, x is 0. If it's less than, it's going this way. If it's less than or equal to 0, the function is x minus 1. And the reason why is because there is a y-intercept of -1. And as we go over, we're going left 1, down 1, left 1, down 1, left 1, down 1. Well, left is negative. So -1 is left, and down is negative. Negative divided by a negative is a +1, and we can put that in our function if you'd like. You can put the 1 in front of the x. Okay, looking at the other side, we are going down 1 over 2, 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 down 1 over 2. So this is our slope. And we are also having a y-intercept of -1. So that is our function. And it's if x is greater than or equal to 0. And what's interesting is that the first one is just less than 0, and the second one is greater than or equal to 0. Just something to keep in mind. Last slide, 25. Average rate of change from a graph. So this graph came from the last problem. And if we are looking at this side, even though it's pointing down, we're going up 1 over 1, up 1 over 1. So it's a positive slope. So our rate of change, which I'm going to call ROC, is 1 for that. And for the blue line, which I'm going to color green, it's going down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. So for in this range, our rate of change is equal to -1/2, which is the same as the slope. So slope and rate of change are the same concept. And that concludes our review for our final exam. Good luck studying, and we will take the final exam on Tuesday and Wednesday.